Dear friends, my name is Silvio Heck and I work by Copec Company, and it's a pleasure to talk about some points regarding to internal mixers for rubber industry. When we talk about the mixers, the final mixers, we have to pay attention about the main causes of defects of the final products, and they are non-uniformity in mechanical properties, lack of homogeneity, low dispersion of ingredients, and air inclusion. These are the most factors for uniformity. To ensure the goals in the mixes process, we have to have in mind the following parameters. Ensure uniformity of properties between different batches. Make the most efficient systems in terms of time and energy consumed. Controls. Some factors should be considered to the lack of uniformity. The first one is non-uniformity in the properties of the ingredients. Second one, mistake in ingredients dosage. Third one, not most accurate controls in the variable processes inherent of any mixing equipment on their peripherals. These three factors, the first two we can manage with some quality system. The third one, inherent to the equipment, is that we can talk about in this presentation, to control the mixing time, by temperature, by time and temperature, and for energy also. Equipment controls. In this slide, we can see some benefits of CLP program nowadays in the equipments. Nowadays, the CLP are very often and are help to develop the functions to these equipments. Nowadays, the controls of the equipments, auxiliary equipments, are very useful. These controls, such as power integrating, feeding conveyors, ham positions, and temperature control units, are more and more useful to the process of the mixing. Another device that is very helpful in the process of the mixers is the integrated power. It's a simple device that connects to the main motor, and you can describe it after in this presentation. Another important control in the mixture is the ham pressure. Nowadays, we can control the pressure over the entire cycle of the mixers. It can be hydraulic system, like this picture, or it can be also pneumatic system. Important device that we use in the mixers is the injection oil. In this case, the injection oil is weight control. Also is very important, we have a feeding materials device for the first master batch. The controls of the mixer by time and temperature are well known in widely used rubber industry. But there are some difficulties in mixing uniformity as a result, come especially in thermal differences of the mixer during the day. To establish the connection between mixer process and power control, we must use of rheology studies such as shear rate and shear stress. In this view, we can see the action of the rotor, and we have a mechanical work T that is produced for the rotor in the compounds. Now, we will suppose that you have a cycle of the mixture where the power is constant to the entire cycle. In this case, the constant power you have during the entire cycle. The graphic area, the power versus times, is our energy that you use in this cycle. In fact, in the internal mixers process, the power is not constant, it's more or less like this graphic. When you use the energy along the process, is the integration of the area of the power versus time. From the concept of energy, can easily reach the concept of a specific energy. That means energy used per unit mass or volume here. This figure shows the test of three polymers with different viscosity and different shear rate and shear stress. And was calculated the energy specific and viscosity for each polymer. So we concluded that the degree of classification of the same is a function of a specific energy imposed on the product. The figure represents the test of typical compounds of tires based on the concept of specific energy. The samples were made in various sizes of different equipments, such Banbury 11D, 1A, 1B. And we make the correlations between a specific energy and the viscosity. We can then carry out the test with laboratory machines and then extrapolate these values to the normal standard equipments of productions. In this picture, we can show the relation between 15 batches with a rheometer for epidemic compounds. We can see the variation of the rheometer curves, and this control was done by time and by temperature. The same test was done by the 15 compounds, and now we can use the power specific energy, and you can see the variation is less in this process. Another important concept is the thermal balance. In this case, we put the amount of rubber to the mixer chambers. Then we have the mechanical work of the motor. and you have also the cooling system that maintain the temperature. We can, in this balance, you can observe that the total amount of energy used in the process only is 37% was used to the polymer. The others, 43% was lost by, and you have more or less 20% by the cooling systems. When you talk optimization process, you have to know exactly the amount of water that you can produce in a mixer chamber. And this amount of Huber is a rate for useful chamber volume, the fill factor, and the density. The fill factor is related to the rotor geometry. In these pictures, we can see the power integration and the time, and you have the levels of energy for each time. When we talk about optimization, we can see these graphics produce the power integrators. In the first one, we can see the oil injection was done in one step. In the second one, the oil injections was done in 2 steps. We can, with this manager, reduce the cycle around 36%. In the recent decades, rotor geometry and thermal capacity of the mixers was a pay attention. The rotors can be divided according to their characteristics. Tangential mixer 2 inch, tangential mixers 4 inch, tangential mixer 6 inch, interconnected mixer or even speed. Another important characteristic to understand is the useful chamber volume. The useful chamber volume is the volume chamber minus the rotor's volume versus the fill factor. And the fill factor depends of the compound that you produce in the mixer process. In this figure, you can see the variations of the fill factor.
In this picture, we can observe the differences between chamber volume for the mixers. For even speed, for example, the mixer's chamber volume, VC, is very large compared to the tangential mixers. That means the even speed mixer has more cooling capacity for the same batch mix. In this example, we compare different geometries for the membranes. 2 wings geometry and 4 wings geometry for tangentials and interconnect geometry. As you can see, for the same batch is a SBR plus EPDM. The discharge temperature was around 160 degrees for tangentials and 137 for interconnect geometry. And the specific energy produced by interconnect was bigger than tangential 4 rings. That we saw this capacity of the cooling is better for the interconnect geometry, and also the dispersion is better because we have more specific energy. One aspect that's very important is the rotor design. In this picture you can see the first old geometry that you use for interconnect rotors, and the second one, the new geometry for interconnect rotors. The new rotor geometry for internal mixers, mix series, are ideal for compounds that need more dispersions, as well more strict temperature. The control over the mixed batch, with this new development, we improve the cooling capacity, as well we improve the dispersion in the mixer process. The tangential rotors are also improved to the thermal capacity. In this example, we can see the cooling system that is very close to the nip to the rotors. In this table, we can see the characteristics from tangential and even speed geometry. Tangential boundaries are more used in the industry tires because it's a robust thermal mixers and great scale productions. Even speed are bigger machines, then are more expensive, but the temperature is low. This is a low desired temperature and high quality mixer. That means more specific energy. This picture is for the lab machines for tangential mixers. The capacity is 1.6 liters, and we have a variable speed from 15 to 240 RPM. And these machines are very useful to reproduce the laboratory trials. Then we use these results to normal productions. This picture is the LabMIC 5000 that is used to interconnect machines. The gearbox is a unidrive gearbox and the motor is a variable speed motors. With this configuration we can simulate our production line. This picture is the lab machines, 5 liters, and interconnect geometry. We have the rotor speed, that variation is 10 to 100, and with these machines we have this CLP that you can manage the variables like speed, hand positions, power, energy, cooling capacity, everything necessary to record and then apply to machines, to production machines. In this table we can see the range of productions for tangential mixers. We can start to small mixers, 25 liters. Then we go to the biggest memories, 420 liters. And you can have the hottest geometry with 2 wings, 4 wings, and 6 wings, depends on the applications. In this table, we can see the interconnect hoters capacity. We can start with small 21 liters, then you can go to 320 liters. All these machines, we have the new hoters geometry with improved cooling capacity as well the fill factor. We talk about nowadays the fill factor around 0.7. And these machines was tested and proved by experiments in laboratory. We hope with this presentation we could help the main users for the mixer machines to understand a little about the mixer process. Thank you very much for the attention.